Hello, my name is Evan Wood, a chemistry student at Radford University. Together with Dr. Fear, I worked on the temperature-dependent stabilities of the fullerene C44. Fullerenes are large, three-dimensional carbon molecules that are shaped kind of like soccer balls. One of the most common ones, C60, is arranged in pentagons and hexagons to form something similar to what you see in the center of the presentation. What I worked with is C44, which only contains 44 carbon atoms, and that's what is shown in the middle of the screen. These fullerenes with less than 60 carbon atoms are especially interesting because they violate the isolated pentagon rule. The isolated pentagon rule shows that there's a lot less stability when there are two pentagons touching in a fullerene. With less than 60 carbon atoms, it is impossible to make a fullerene that does not have two pentagons touching. However, despite this, C44 has still shown itself to form in people's experiments. In one experiment, it even was produced in a greater quantity than C60, which is a more stable molecule. This is where a thermodynamic study comes in handy, where we can see what temperature C44 will be the most stable, and this will help scientists in the future to synthesize it. The program we used was Gaussian 09W, and we used the density functional theory in order to find the different energies and stabilities of each isomer for 4 different metal fullerenes. In the center you can see our data listed in data tables for the pristine isomers, the calcium isomers, and the potassium isomers. And the only difference here is the atom in the middle of this cage. So in all of these, we found that isomer number 75 was the most stable. This actually correlates with the previous research study where they predicted that number 75 would be the most stable too. However, 89, which is just below it in all of our tables, is only a marginal difference in its stability. And this is where, again, the thermodynamic study would come in handy. At different temperatures, the stabilities fluctuate, and in one case, number 89 might actually be more stable than 75. However, we did not have time to get to this part in our research, and this will be continued later on where we will find the full temperature-dependent stabilities, and we'll be able to compare each isomer then. I would like to thank Dr. Fear for his assistance helping me throughout all of this semester, and I'd also like to thank the Office of Undergraduate Research and Scholarship and Dr. Wirgo for their help on my research and allowing me to do this all. Thank you.